everybody. Our last lesson covered the measure of various segments, and this lesson we're actually going to talk about when two segments have the same measure or the same length. Okay, so when two segments have the same length, they are called congruent segments. Okay, so let's say that we have a segment AB. So we'll put a point A and a point B and create segment AB. And then let's say we have another segment BC. So we start at B and go to C. Segments AB and BC are congruent if the distance from point A to point B is the same as the distance from point B to point C. So if A to B was 5 units long and B to C was also 5 units long, then you would say that segment AB is congruent to segment BC. We show that by putting a little slash mark on segment AB and then the same slash mark on segment BC. Or maybe you'll see 2 slash marks from AB, but then you would need to see 2 slash marks from B to C to show that AB and BC, those segments, are congruent. To write it out, you would say AB, that segment, is congruent to BC, and the symbol that goes in between the two segments looks like that. So that says that AB, that segment, is congruent to segment BC. So what we're going to do now is we're actually going to calculate ourselves the measure of two segments and then figure out whether or not they're the same and therefore congruent. Okay. To do this, we're not going to use a ruler. They're not going to tell us exactly what the segment measures are. We're going to plot points on a coordinate plane, which you've done before, and then calculate the measure between those 2 points, or calculate the distance between those 2 points. Okay. To do that, the first thing that we need to do is graph the points that they give us. Alright, so the first point they give us is point A, and it says that point A is a coordinate point -3, 2. Okay, so the -3, that is our x coordinate, which means we are going to go on the x-axis, and since it's -3, that means we are going to go to the left 3 units, which would be over here. And then the y-coordinate, here's our y-axis. Our y-coordinate is 2, so we are going to move up 2. So we're going to go 3 to the left and then up 2. So count over 3 to the left and then up 2, and that is going to be our point A. Point B then is the coordinate point 4, 6, which means we're going to go 4 to the right and then up 6. That puts us up here, and that would be our coordinate point B. By connecting A to B as straight as possible, we've created segment AB. Okay. From there, we want to find out what is the distance, how far is it from point A to point B. And that is what this distance formula is. So the distance between point A and point B can be calculated using this formula right here, this distance formula. Okay, so the first thing, if you notice on here, it says x2 with a little subscript 2 minus x and then a little subscript of 1. That just means your first x point and your second x coordinate. So here for point A, this is one of the x coordinates. This would be x1. And then here for point B, this would be your second x coordinate, so we'll call that x2. Then here it says y2 and a y1. Well, those are our two y coordinates. So this is our first y coordinate, so we'll call that y1. And this is our second y coordinate, so we'll call that y2. Okay, so from there we're going to follow this formula. I copied it down here so we could use it again. And we're going to find out how far is it? What's the distance between point A and point B? Okay, so we'll do D for distance, and then I usually put a little subscript AB to show that I'm finding the distance between point A and point B. And that equals the square root. All right, and then we have a parentheses. We're going to do x2. Well, we've labeled that already. That's 4 minus, and then x1 was a -3, so minus -3. And then we square that, plus, and then y2 was 6, minus the y1 is 2, and we'll square that. Okay, let's keep going. So now the distance from point A to point B. Okay, right here where we have minus -3. When you have minus and negative, you know that can become plus. So 4 plus 3, that's 7. We still have to square that. And then in parentheses over here, 6 minus 2, that's 4. And then we have to square that. Alright, so the distance from point A to point B is the square root of, okay, 7 squared means 7 times 7, which is 49, plus 4 times 4, which is 16. So here the distance from point A to point B is the square root of 49 plus 16, which is 65. Okay, well, we know that the square root of 64 is 8, so the square root of 65 should be a little bit bigger than 8. We can use our calculators to get a better idea, and it's approximately 8.06. So the distance from point A to point B up here is 8.06 units long. Okay, so now that gives us an idea. Rather than us just putting, oh, from A to B is 8.06, we actually calculated it for ourselves. So now what we're going to do is the exact same thing over here for part B. We're going to find the distance from point C to point D. Okay, so first thing we're going to do is we're going to plot point C, which is -1, 2, which means we're going to go left 1 and up 2, and that's going to be point C. And then to find point D, we're going to count 6 to the right and then down 2 and label that point D, and then connect them as best you can straight, and that would be our segment CD. Now we want to find out, well, how far is it from point C to point D? Okay, so let's label point C as our first coordinate. So we're going to call it x1 and y1. And then point D is our second one, so we'll call that one x2 and y2. Alright, so now we need to find the distance from C to D by following the formula. I'm going to move this down. The distance from C to D, follow the formula, put a square root, parentheses. Now we have to do our x coordinate, our x2, which is 6, minus the other x coordinate, which is -1. So 6 minus -1, and square that. Plus, then we have to do y2, which is -2, minus y1, which is +2, and square that. Okay. So here we have 6 minus a negative 1. So remember, then that can become plus 1. 6 plus 1 is 7. Square that. Plus negative 2, take away 2 more. That leaves us with a negative 4. And then we're going to square that. Okay, now our distance from point C to point D is 7 squared, which is 7 times 7. That's 49. And then this negative 4, when you do negative 4 times another negative 4, you get positive 16. So then when you add the 49 and the 16 together, you get the square root of 65, which is approximately 8.06. We can find that using our calculators. Now, if you notice then here, the distance from point A to point B was 8.06, approximately that many units long. Same thing for the distance between point C and point D. So based on what we talked about earlier in the lesson, we can say that segment AB is congruent to segment CD because they have the same measure. It's the same distance.